Hello, this is Scooby. I'm the team leader of this group. Project Summer is designing a compact weight scale controlled by a smartphone interface, providing a precise measurement from 1 milligram to 10 gram. The accuracy is one of the most important part, whose 0.1 milligram. And this is the introduction part made by all of us at this group, and I was writer one. I wrote everything at this project. This is the problem statement and its identification. It's also important part for this project. Existing scales like accuracy, portability, and smartphone interface. And there is a need for portable weight scale that seamlessly with smartphone, providing a measurements on the go which is accurate. This is the research part. It was made by me. Requirement specification made by all of us at this group, and engineering requirements made by Aykan and me. And this is the marketing, Kutay and me. And this is the constraints part made by Anil and me. This is the standards part made by Sami and me. It is, I think, one of the most important part for this project. Detailed design made by all of us at this project, at this group, and of course some of us put more than us. And these are the equipments. This is the equipments. Application was made by Kutay, and this is the level 0 design, level 1 design, and level 2 design made by Kutay and Aykan. And Aykan made the diagrams. This is the explanation of this project. This is the normal looking. This is the project plan with Gantt diagram. These are the responsibilities at this project. You can see anything what we did at this project. And after that I made the risk analysis, and this is the alternative plan made by Sami and me, and there is an Arduino code right here made by other people except me, and they wrote it. And this is the cost analysis made by Anil and me. This is the conclusion made by all of us. We made meetings at the Zoom, and we created this.
I am Anlay Demir. We researched the materials with Sami. I will talk about the equipment we used in the project. We used the ESP32 as the main board that forms the brain of our system. We choose to use this card because it supports communication protocols such as SPI, as well as having Wi-Fi and Bluetooth integration. The other equipment we use is the regulator. The regulator converts the electricity coming to mains to the voltage suitable for the processor. We use the battery power to scale when the scale is not connected to the STIGRIG. Thus, we have made our project more useful. We have added a relay card to our system for this. Relay card enables our system to work both with electricity and with battery. Another part we use to measure weight in our system is the load cell. The load cell provides precise measurements. These are also jumper. We have provided the connection between the equipment. We used HX711 to amplify and process the electrical signal generated by the load cell. The HX711 enhances the signals from the load cell.
Hello, I'm Ktoyoksus. I had with various topics and today I will explain some specific parts. I designed application section myself, focusing on user-friendly interface where user can easily use and with measurements from scale in real time. In the project, we want to ensure that device does not draw voltage from the battery, especially when it's plugging into power outlet by using regulator to reduce 220 volts power supply and incorporating relay usage. We connected the device activation to user button. With the help of the ESP32 module, we are able to connect the smartphone without using an additional Bluetooth module, allowing us to view information from the load cell synchronously on the smartphone screen. Yes.
Hi, my name is Mustafa Aykan Karakaya. We created the engineering requirements of the project together with Kubilay, and I helped others in writing Arduino codes. In the design phase, we worked with Kutay on the communication and connections of the components. After all this, I made my main task. I created the level 0, level 1, and level 2 designs. We see the simplest version of the project in level 0 design. When we look to level 1 design, all the components that make up the system are seen. And finally, we see the most detailed version of the system in level 2 design. All components and device connections that make up the system are seen in this design. And you can also see the article that describing the working principles of the systems in here. And thank you for listening to.
Hello, I'm Ahmet Sami Görgü. I took care of the alternative plan creation part. In addition, I helped Anıl them in the equipment department and Akutay Öksüz in the coding department, and we took joint decisions. With the alternative plan, it became a project with a lower budget and lower calibration compared to our main project. We switched from 10 gram load cell. We used to 5 kilogram load cell. Another element was found to replace intermediate element HX711. And as a final change, we took off sending data to LCD display instead of the font. That's why we used the Arduino Nano LCD display instead of the S32 IoT. Kubilay Güner helped me with most of the alternative plan. We got help from sample codes for coding. We coded certain functions and researched them in details and made them work.